Hello everyone, this is Amir from Audio Science Review. I thought I'd start a new series covering some of the text reviews that I post on the website. If you go to audiosciencereview.com and click on this Reviews tab, you see a list of every review that I've done, and if you keep scrolling down, more and more will show up. Instead of doing a video on each one, which can be very time consuming, I'm probably too lazy to do that for you. You're welcome to go read the text reviews. I thought I'd do a sort of a roundup of the reviews of the week on this thing and try this as an idea and see if it works well. So if I go back a week or so, by the way, in here you also see third-party reviews by other members. This one, for example, is by somebody else. So I'm only going to cover the reviews that I've done. Go back a week or so. It takes us back to this product. It's a cheap little Phono preamp from a company that's kind of famous for these budget products, Art Audio. And a member gave me the money, $100, for me to go buy and test this product. So I went ahead and purchased it. It's $100 on Amazon. And it's actually a cool little box. $100, you're not going to get fancy enclosures and what have you. But it's got a fair amount of controls, and the buttons actually feel pretty good. But what's unusual about this device is that it's not just an analog preamp for phonos, as is commonly done, but actually it has a digitizer that lets you capture that audio in digital domain to USB, so you can basically rip your LPs, as some people call that. And you can see that, excuse me, on the back where we have a USB connection. It also supports SPDIF and what have you. You can actually select to use this device either as a phono preamp, meaning it has a lot of gain, to just having low gain and be a line, an audio interface, if you were to buy a professional audio capture device. So you get both functionality in one. That lets me test each part of this device separately, so I can test this capability to just be a digitizer compared to all the other ADCs that are out there, and then test it in combination with a phono preamp. So starting with that, the way that works is that from my audio precision analyzer, I generate a 1 kHz tone. I have to set it to some voltage. For unbalanced audio RCA, I set it at 2 volts, and then capture the output digitally, and then the audio precision analyzer is able to analyze that digital bit stream just like it can do so on analog bit stream. So we see our 1 kHz tone that we put in, but unfortunately we also see all these distortion products that are created by the analog to digital converter that's inside this box. I've set the gain in here enough so that I get to 0 dBFS, which is the maximum digital value you can get, but without going over, because if you just go over a hair in digital domain, these distortion products shoot through the roof, and that's the problem with digital. It's great until you saturate it, and once you saturate it, hell breaks loose. So I've set this at 2 volts and measure that, and if you combine all the distortion products and noise and compare it to how strong the input signal was, which is this 1 kHz tone, it's about 80 decibels below that. So the energy of all this stuff is 80 dB below that. So what does that mean? Well, we can plug it into a simple ranking of all the ADCs that I've tested, both consumer and professional. And unfortunately, this lands in the red category, meaning that, you could do a lot better. Ideally, we like to see everything in green, and then, it's wonderful when we get something in blue. But now this is a $100 device, so we can't be too critical for the class of device it is. It's not bad. It could be better, but it's hard to complain. Its noise performance is just a little bit better. Signal-noise ratio is about 87 dB, whereas distortion is about 80 dB. So, it's not bad, and certainly a lot less noisy than the LPs that you're going to capture. The groove noise alone is in the 30 dB range. So you have plenty of quietness in there, in the capture device. At 2 volts is a little bit unhappy. if I sweep from 5 millivolts to 2 volts, we can see around this point, all of a sudden, it starts to generate distortion. So the cleanest signal is around minus 4.2 dB voltage. And I think I have that somewhere else coming up later on what that is. Or do I have it here? No, I do not. But anyway, it's about 1 point some volts or so. That's the limit if you want to use it as a capture device. But, you know, the main purpose is digitizing LPs, so let's switch it to that mode. And what that does, it generates a lot of gain. I think it's about 40 dB gain or so. There's a nice little, I shouldn't say nice, there is an indicator in here that says clipping. If I adjust the volume to here, as you can see right in that arrow, that's barely the point where this light wants to come on. And if you did that, you're actually capturing at 10 dB below maximum volume, maximum output. So, but that's actually a good thing, as you'll see in a second. So with the gain set lower, and we measure that, and because of the RIA equalization for LPs, the Phono preamp needs to have a lot more gain in bass frequencies, and that causes it for this noise to be elevated here. So normally we get a graph like this, but ideally you wouldn't get all these spikes in it. I have to deal with it a lot because phono stages are very sensitive and they can pick up a lot of noise. And usually I find one way or the other to reduce these spikes down to, you know, if it's good implementation, I get it down to almost invisible. In this case, the device was very sensitive to noise level. The shape of this graph and these spikes, and this is the best I got. If you just plug it in, is horrendously worse than this. And, you know, maybe in your situation, you can get it to be better, but you may also get it to be a lot worse. So it seems that the phono stage is picking up noise from what's adjacent to it inside this little box. Our SINAD, which was 80 dB for just at low gain, now with phono mode turned on with both equalization and high gain, and we lose quite a bit of it. We're down to 59 dB. What does 59 dB means? If you run the exact same test with the same 5 millivolts of input, simulating what a moving magnet cartridge would produce, the ranking is the 4th worst one that I've ever measured. So definitely not a good showing. You know, an average device would be in the 70s, and state-of-the-art or best ones I've tested is around, you know, mid-80s. So we're leaving a lot of performance on the table, and unfortunately it's in the noise department where you can't hear it. You know, distortion here is at minus 80 dB. Your cartridge and LP system is going to have a lot more distortion than that. But here, you know, you could be hearing noise from this product. On this thing. Now, one of the most important things in a phono stage is how good it applies the reverse equalization. If you're not familiar with that, to best optimize this limited format that's called LP, we pre-equalize the response at recording onto the LP, and then we do the inverse in the hopes that we get a flat response. So the job of the phono stage is to back out that equalization with inverse filtering, and ideally you get a flat line in here from 20 to 20 kilohertz. And a few phono stages are almost there. This one's not quite there. You get some variation in there, but it's really small. It's about a half a dB or so error here on the positive side and 0.2 dBs on the negative side. So for a phono stage, especially a budget one, it's quite good. You know, you'll have a bit of exaggeration of high frequencies is what this has on this thing. It has a nice subsonic filter, which in my opinion should be a standard feature in every one of these phono stages. And when you do that, you know, you lose response starting at 50 hertz. Whether that's a good response, you know, probably not. You really want it to be flatter to a little bit lower and then drop like a rock prior to that. But it's certainly good enough, and it's switch selectable, so you can decide on this thing. The SINAD in the dashboard is heavily influenced by noise, as I explained, but the analyzer is able to actually exclude the noise, and we can look at the distortion, and we see that at 10 kilohertz, distortion is very, very low. We're at minus 90 dB. We're talking digital audio, you know, domain, but it increases to minus 60 dB because of that RIA equalization, so that's just normal. Now, one test we run is to see what is the overload margin. I mentioned that I measure the dashboards at only 5 millivolts in, and that's a typical average for moving magnet cartridge. But when the LP is spinning, if you have any noise or pops and static from it, those can actually have quite a bit more amplitude than the 5 millivolts. So if you reproduce this precisely, you hear X amount of noise. But if the phono stage actually clips, when it's trying to reproduce those pops and ticks, it will actually exaggerate them substantially. And so to get a quiet playback, as quiet as the LP can be, despite all those noises, you want to have a lot of headroom in there. So we run a sweep where we're actually running at very small values. Here is 0.1 millivolts over here, and go all the way to as high as we can to see when clipping happens. And the clipping is in this case, being a digital device is kind of tricky in that, remember what I said, once it reaches 0 dB, all bets are off and it saturates. So you have to fiddle with that gain stage to try to find a position where it's not clipping, but at the same time it doesn't get too quiet as far as what it's amplifying. Even with my optimizations, best case that I got on this is 79 millivolts before it saturates and clips. And look at what happens when it clips. Distortion shoots up to 100% distortion here. So we're not talking small amounts of distortion. We're talking just, basically nothing but, crud coming out of there. I'd like to see 100 millivolts over here as far as the headroom. So 5 millivolt is playback. We like to see it allow up to 100 millivolts before it saturates. And here we stop at 79 millivolts. Is the end of the world? No. If your LPs are clean, it's probably okay. But just know that there are better phono stages without this problem, and partially this problem is created by the fact that we have a digitizer in front of this, and it can clip very easily. You can see if you set it incorrectly, where the gain is set to what the device tells you right before it goes red, you only get 13 millivolts of headroom before it saturates and goes to 100% distortion again. So, you want to back it off even more than that. And if that makes things quiet, hopefully your power amp can compensate for it. So you can read about the specs in here. So overall, to me, the problem in here is this noise susceptibility here. I like it to be much more quiet than here. Yes, it's a budget product, but we gotta have standards in there. So I think it's unfortunate that they didn't manage to keep the thing more quiet than they could. They gave up a lot of performance. We got 58 dB instead of where we started, where it's 80 dB without the phono stage activated. So expect a few dBs of loss, but not as much as we have in here. Okay, so it's not one of my favorite products. Some of their other products are better. So why don't we go back and see what's next? The next one is wound up to be a very controversial product to test. There was a speaker from Yamaha called NS10. It was a consumer speaker that was sold in Japan and then brought to America and I imagine other countries. And it basically lived his lifetime, and it was basically a failure, and that Yamaha was going to discontinue that speaker. But somebody grabbed it, and the story goes that somebody in Tokyo saw one and grabbed it and started doing a mix on it and creating music, and thought that this speaker did a better job of telling them what was wrong in their mix than their proper professional speakers. Well, that idea caught on fire. Somebody else grabbed it, and next thing you know, thousands of these speakers with this iconic white cone are being bought and placed on top of the meter bridge on the console. And this thing became the most ubiquitous speaker there is for production. We're talking, I think, 90s and 2000 or 80s. I forget the dates that it was very popular in. And eventually the speaker was discontinued, and I think it's been 20 years or so since it was produced. There's been a lot of requests to measure the speaker. So I went on eBay trying to find an NS10M, and everyone that I could, M was the studio version, which was basically the same thing. And all I could find was crusty samples with literally mildew and watermarks and, red, yellowish cones and speaker, beat up cabinets, and they wanted hundreds of dollars for these things. And then I remember reading that people said there's a new version of this thing has been implemented by a company called Avantone Audio, Avantone Pro. And they call it CLA-10, named after the mastering engineer that helped them with the design. And they claim to have found a woofer that's almost the same or the same, and the same tweeter, and they built the box exactly the same, put it all in there. And people say, hey, you could test this one as a proxy for the original. And the good news about testing this is that it hasn't aged, whereas if I test a 20-year-old Yamaha NS10, who knows if the drivers have degraded and whether that's representative of what was there before. So I believe that, and this product seems to be getting a lot of positive marks on different YouTube videos and reviews that I read, where people say, yeah, it's a little different than NS10, but otherwise, does the same thing. So I said, great, why don't I test this? Nobody volunteered to send it to me, so I had to pony up $700 on Amazon to buy this thing, and it arrived. Now, it turns out right on the year that this product, the original Yamaha, was discontinued, a study came out by fairly experienced consultants, Philip Newell, somewhat well known in acoustic circles and certainly in the pro industry. And they actually had a contract for Hi-Fi magazine or Pro magazine, I don't know which, to go and measure a bunch of professional monitors, and they also measured the Yamaha NS10M. And if in an anechoic chamber. So if we start with that, we can see the frequency response they measured on the NS10M. It's not anything we'd want to see in the speaker. So it's a sealed enclosure, so that's this sort of a constant slope going up. This is the base response, but as soon as you get to 200 hertz, the response starts to climb, go up, 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 and then it drops like a rock, and then you have these resonances, which are basically a woofer breaking up. Normally, you want to really filter out the woofer response, let the tweeter take over and produce and mix the two so that the two get a constant amplitude, so we get a flat response. But here, that was not attempted, so we get completely uneven response. So up here, we're at 95 dB. Down here, we're at about 86, 87 dB. So an 8 dB rise, sort of a gradual rise, and then drop like rock, and then resonances. So, if I were to, test that speaker today and saw a response like this, it would be just horrible. I mean, you'd never want to use a speaker like this for production. So, question is, how does that compare to the Avantone CLA-10? Because is it a proxy of it or not? Did they do a good job cloning it? Turns out they did not do a good job of cloning it. So let's look at the response there on my system. Now, keep in mind that my measurements are higher resolution than what you see even in that anechoic chamber. So it's more authoritative than that. But we sort of see a similar trend with the same closed box response over here, and same gradual rise, although it doesn't look anywhere sort of like a flat slope that they had. We see a sort of gradual in here, shelving thing, then it sort of goes up and it comes up here. But instead of dropping back down like this one did, we don't drop back down. We actually go down here. There's a peaking resonance here at the narrow frequency, and then the response actually stays quite hot till you get about 6 or 7 kilohertz. And then at 6 or 7 kilohertz, it sort of shelves down, but then it has another resonant peak in here, then eventually dies off. Another horrible performance in here. It sort of starts off good, but look at this mess in here. So obviously anything you play through it is going to exaggerate sort of lower treble and all the way up to most of treble range, and then it kind of drops off. And so you basically don't have much bass, and all you're going to hear is upper mid-range and treble with some nasty resonances over here. The second thing we do that's advanced that wasn't done then is that we look at what is the directivity of the speaker, which means how similar are the on-axis versus off-axis response. As we predict, in that if you just take a woofer and tweeter and just slap them in the front of the box and don't attempt to shape the waveform that coming out of that tweeter widens its response as soon as it takes over from the woofer, and therefore the sound that you hear off axis will not be even. I have done videos on that, and maybe I'll link in the description for you to go watch on directivity errors. And we have a classic major directivity error, which means that up to about 2 kilohertz, the on-axis and off-axis are similar, but once you go past 2 kilohertz, all of a sudden there's strong variation between off-axis and on-axis. What does that mean? That means if you take this identical speaker and put it 2 different rooms, it's likely going to sound different because those reflections, whether they're absorbed or not, whether they're close to you versus not, is going to change the tonality of the speaker. So despite what people thought at the time that, oh, the speaker is great, you know the sound of it, you go from room to room. No, you don't necessarily know the sound of it, because there's room dependency in here due to directivity error. At the time, people didn't think that stuff was as important, even though the knowledge was there, but they didn't know that. So at any rate, we have that classic directivity error as well. So quick thing is, no, this speaker is not a replacement for NS10M, and it's more broken than what I call a broken. So NS10M was broken, and this was a more broken version of that on this thing. So if we look at what's broken in it, and we can see the woofer in here, if I just measure it by sticking the microphone close to it, we can see the woofer response comes in here and gets kind of jagged and screwy over here. But as this response goes out, then all of a sudden we see these resonance peak over here because the crossover filter isn't steep enough to kill them. And then at the same time, we see that the treble, has also non-flat response, and the tweeter has non-flat response, and you combine this with this, you're just going to get a mess. The crossover frequency is 2 kilohertz, and it's just not how you design speakers today. Clearly, the designer had the wrong concept there. There is some good news in there, because the speaker is not being pushed to produce much bass. It's actually pretty low distortion when it comes to bass. But if you do push it, it's still a small speaker. So at 960 BSPL, it does get distorted in bass, which we're not very sensitive to, but we sure as heck are sensitive to the mid-range distortions and treble distortion, and we got plenty of that over here. And anyway, I show this distortion both as a relative and an absolute. Relative one is the one that you want to look at most of the time, unless we have a reason to look down here. Typically, we have 2 models for predicting how a speaker performs when we measure it in an anechoic response versus if you put it in your room. And one of the things we do is that we look at what's the typical strength of the reflections coming out of the speaker. We have the on-axis sound, but also what sound hits the walls and comes back at us and combines. And we take all the early reflections and we sum them together and get one line, which is this green line. And we like to see this line be very similar to the on-axis response, because then it'll mean that off and on-axis sound similar. And usually the trend is that they're similar, but there's less energy off-axis, because you go sideways to a speaker, you hear less height. This speaker is the opposite, in that you go off-axis, the sound is actually brighter than the on-axis sound. This arrow that I've drawn usually points down, is actually pointing up. And at any rate, is kind of screwed up. Now, note that in near-field use, this model doesn't work as well, although I should say all the well-designed near-field monitors do superbly in this department as well. So it's a good proxy to know how clean the off-axis response is, even though in absolute, this model doesn't hold on this thing. So where's the problem? We actually see that the problem is when you have the speaker in the in the vertical axis is where it's got most errors on this thing. So horizontally is actually not as bad. One of the worst things is actually the reflections behind you. You want to try to absorb that. By the way, the speaker can be mounted vertically or horizontally, and so depending on which way you mount it, you switch this for that and vice versa. I tested it vertically, even though you usually see it on meter bridge horizontally. It's actually vertically cleaner sounding, measuring than it is horizontally. So if you do have it, I highly suggest that you have it, vertically than horizontally. The reason for that is you can see how good the horizontal reflections are when you have it vertically. Hope you can keep up with me. Speakers placed vertically, and here we're showing the horizontal reflections. So what hits the sidewalls in the studio and comes out your ears is actually pretty good. Vertically is bad. But we're less sensitive to that. If you turn it on its side, as most people do, then this becomes your horizontal one, and all these bad reflections are not what's audible and hits the sidewalls coming out your ears. So do not use this. And if an S10 was anything similar to it, do not use it horizontally like everybody seemed to be having on top of their meter bridge. They should have used it vertically to get a more correct response. Just like earlier reflections, this arrow should be pointing down, so it's pointing up. When it's pointing horizontal or up, by definition, it's going to sound very bright. And we don't like that, and that's what you're going to get. I won't go into this stuff. You can see it. You can see the directivity errors over here and so forth. The paper talks about one of the reasons this is a good speaker is that it didn't, it didn't have resonances that lasted for a while, and therefore was a fast-sounding speaker. That whole concept of fast or slow is actually a complete myth. It doesn't. Science tells you there's no such thing as fast or slow. You either have resonances, which means that things linger in time domain, but if you have resonances in frequency domain, you get those peaks that I showed you. And indeed, if I run my waterfall graph in here, you can see all these elongated things. And if you walk them back, you can see peaks everywhere. There's one of these things. There's also a peak there. And so you don't even need this waterfall. If a display is not, if a frequency response is not flat, it's got these peaks in it, then you have resonances. Unfortunately, when Newell and crew measured that, they set this very long time frame of 100 milliseconds in there, whereas I only have 4 or 5 milliseconds in mine. And so all of these resonances probably died off before it got here. Or it's possible that the original Yamaha is much cleaner than this Avantone. I can't tell you till I test one of those. But to me, I don't think this data is authoritative, and I think it probably had resonances if you had high-resolution measurements and tested it. One thing that, I usually don't comment on step function because it's just a useless measurement in general. But here we can use it to see if this speaker has similarity to that design. We actually see that it does. So our step function is matching that of the anechoic measurements of NS10M. If that's the case, that means this could also be representative of NS10M, in which case it means that it wasn't a fast speaker anyway. It was just a myth thinking that it was fast speaker. There's such strong resonances, you can actually see kinks in the impedance graph at higher frequencies that often don't show up. So here's the response on that. As far as listening tests, I listened to it, and the first track I played on it, I thought I'd wired something wrong. I was just not hearing all of the music. It was like a three-way speaker that the mid-range wasn't plugged in or something. And then I switched to another track. It was like, oh, no, it is sounding kind of okay now. So is really that when you screw up the tonality of speakers so much, it's emphasized and de-emphasized so much that it feels like some parts of the music are taken out and other parts are pushed forward. And I have not heard a speaker sound this bad. And not only is the tonality wrong, but there's a ton of distortion in high frequencies. It's just all those, the jagged response and resonances just create odd, grungy sound on this thing. So bottom line is, do not buy this speaker. I don't know why you would want to buy the speaker. People talk about using these speakers so that the mix translates better. I don't know how on earth using a broken speaker with its own resonances. They're adding colorations to the mix and exaggerating response in a way that even crappiest headphones or speakers these days don't do, would tell you something about your mix. Whatever you change in your mix because you hear it on this speaker but don't hear it on another one, you shouldn't be making those corrections, because we don't want to use speakers like this. We don't use speakers like this. Even the most budget speakers today, crappy ones, have better response than this, flatter response than this. So to the extent this speaker finds flaws for you, you think that's in your mix, if those flaws are not audible on a proper studio monitor, don't go chasing those and go fixing things that don't exist, because when you do that, you're now compromising performance on a proper monitor and a speaker. And we as audiophiles want to, we'll deploy systems that are neutral. We do not deploy speakers with responses that, look like this. So for you to do any kind of mix optimization based on this, you're making a mistake. If you're hearing this resonance in here and you pull down that part of the mix, well, we don't have that resonance. We don't have this large hump. So to me, this entire concept of mix translation, this helps with that. Whether it's this one or original NS8, it makes no sense to me. NS10, sorry, it makes no mistake to me. So this is a discussion we've been actually in this thread. We have the people from pro industry defending this kind of practice, to death. And now I'm coming out and with arguments that I've been just making, that this is just the wrong thing. In video production, we have standards. Basically, we define what's neutral, and both the production and reproduction match the same standard. So if you do that, color red will look like proper color red that was seen when the video content was produced. Same thing's done in photography to some extent, although people don't look at photos anymore in same light, but still you use a calibrated monitor to do your photo editing. But audio doesn't have anything like that. It's just what I call Wild West. People come up with these weird ideas of how you use a speaker like this to better optimize the sound for every playback device. It makes no sense to me. The only thing you would be optimizing is for another playback device that looks like this. And in the old days, yes, we had clock radios and crappy stock radios in our cars where people listen to a lot of music. And so, yeah, maybe it could produce this kind of mix and it would be good. Today, we've gone way past that. We have digital delivery of music that's extremely high fidelity. Even earpods are very good, and none of them look anything like this with this kind of response. So anyway, long arguments going on in the thread. If you want to join the pro or against what I've been talking about, you're welcome to go there. As you can see, it's gone on for 26 pages. But the votes are pretty consistent. 133 people, 91% think that this is a terrible speaker. And I usually have a policy of not returning products after I review them. And I get stuck with tons of equipment that I'm the last owner of it. But this one really bothered me, that it's been sold as a clone of NS10M, and it has little to do with NS10M. So it should be its own model, its own thing, and the company should not market it this way. And as a minimum, should have done a measurement like I did to verify it looks like NS10M. They could have easily modified the Twitter response to make it look like NS10, but they didn't. They could have gotten a good sample of NS10 and done that testing. Anyway, so that's that. Long review. Maybe I should have done independent reviews. I don't know. Let's continue on. Maybe watch this whole thing for 2 hours when you have plenty of time. We're 32 minutes into it. So the next one was an odd bird. I don't test many CD players. There's not that much interest in CD players, but occasionally somebody, one of the members, has a CD player, and I figure it's good to test things once in a while, categories we don't bother with. This is hopefully I'm pronouncing it right, Cayin, Chinese company, actually fairly well-known Chinese company of DACs and audio products. And they've made a CD player for $279, and I thought it looked pretty good for $279, all metal box, kind of nice large display in here, slot loading, transport, you want to have a drawer that opens, but slot loading, it works. I thought, if I just post the reviews of measurements of this device, how do you know what that means? So I went to my dusty cabinet and took out this LINN CD player I bought 1999 or year 2000. It's the MIMIK model. If you don't know LINN, it was a company that was very famous for their turntables, but when digital came, they got into digital. They're still around. And at the time cost $1,600, which was a lot of money. If you convert it to today's currency, it's $3,000 today. So to pay $3,000 for the CD player, which then you could buy a $100 one, and today you can buy a $100 one. It was a lot of money. Does it do better than this one? We'll find out. It's digital, so bits are the same. I made a mistake in first. I lost my old test CD, and I went and made a new one and made it on Windows and used the Windows Media Player to make it. And I did not realize that the Windows Media Player actually applies loudness compression, loudness matching for all the tracks that you give it by default. So it took all my precisely created test samples and butchered them to some extent. So that made some of the measurements faulty. Luckily, a member on the forum saw the same thing, having gone through the same process of creating the CD, and he found out the auto leveling in WMP, and kind of embarrassed him because the Windows Media Player team was one of the teams I managed years ago, 15 years ago, so all embarrassing. But anyway, the measurements now are correct, and they use the right test signals that I burned on them. So we go ahead and feed the CD player 1 kHz tone, and what we see is these pretty elevated distortions in here, and the SINAD is just 83 dB. Remember, I just tested an audio interface for $99 that had SINAD that was close to this. So this is not a good SINAD. Dynamic range of CD is about 96 dB if you don't dither. If you dither, it's 93 dB. So we're 10 dB higher distortion than the theoretical noise floor of the CD. So basically they have a $1 DAC in here, and not a lot of effort was put in there to make it, high fidelity. So if you're buying this transport for analog output of it, not a good idea. So now how does it look if you take my expensive, today's $3,000 LINN high-end CD player? How did it do? It did 5 dB better, 88 dB, but the distortion is still way higher than it should be. So even then, you paid all that money in year 2000, 20 years after the CD format was introduced, and you still didn't get, what the bits were telling you to produce. Every time you fed it 1 kHz, you got a cluster of distortion that came with it. So pretty disappointing. This number should have been in 90s and not 88, but certainly better than this one at 83 dB for the Cayin. So now let's switch to digital output. You would think a digital output SPDIF would be then identical to the bit stream that's on the CD. It's all bit exact, it's all digital now, there's no DAC involved. So before we go there, let's look at how the LINN player handled that. And we see our 1 kHz tone, and we see this constant noise floor and no distortion. Digital is digital, and there's no room for distortion. And as I mentioned, a dithered 16-bit format in CD has the best case dynamic range of 93 dB, and which then turns out to be the SINAD because we have no distortion. So this basically measuring this noise floor, which is determined mathematically to be about 93 dB. So, and the output is 0 dB FS, which is what we told it, and the frequency is basically 1 kHz. So everything's perfect with the LINN. Good implementation, as it should be. But it's not perfect on this Cayin CD player. It actually is producing distortion products. Like, how could that be? I mean, how do you get distortion when you haven't converted the bits to anything else? Well, the bits have been somehow modified. If you look at these things, they're running at odd harmonics in here. Actually, it's odd harmonics. You go 1, 2 kHz and it skips and goes to 5 kHz and so forth. So there's a pattern to this. And what I think is happening is that one of the bits is either toggling incorrectly or stuck 0, stuck 1. So it actually has a basic problem in that the bit stream that's coming off the CD is getting corrupted and going out. A simple test would have caught this, but it was not. And so we're getting distortion even coming out of SPDIF on this thing. And so not good at all. Digital is not digital, bits are not bits. And we actually even get a slight level difference because of that. So not good. If you thought you just get this, hook it up to a DAC and life would be good, it's not on this thing. So the Cayin, though, it's a little bit more quiet. So about 92 dB versus 90 dB for LINN. We can look at their filter implementations. They're the typical, what I call lazy default filters in the DAC, in that instead of sharply jumping down at 22 kilohertz, they sort of slope down. But that's the same as the DACs by default. That's what they produce as well. And we see that the LINN actually has got a problem in that it's not attenuating out of band response. An ideal DAC would go here and would go down to infinity 0. Instead of that, we see that it's got a high noise floor in here. And the Cayin actually has much lower noise floor. So, it's sort of mixed message, which one of these CD players is better on this thing. We can measure jitter. The bits that are coming out of SPDIF, yes, it's digital. The data is consistent, but the bits can actually toggle back and forth. And that toggling back and forth when fed to a DAC, if it can't filter that, it actually results in analog distortion. So if we feed these two signals, it's a little hard to interpret this, but these spikes are supposed to be there as part of this special signal that's in there. So pay attention to this noise floor. We see that the LINN has a sort of a consistent noise floor in here. It's kind of flat, but it sort of slopes up, whereas the Cayin, it goes in here and it actually rises up here and then it goes back down to a lower level. This says that this clock has some jitter, but it's low frequency jitter. It's not, rapidly changing. It's just slowly changing. So it's sort of a mixed message, which one's better on this thing. So I can actually look at the spectrum of that jitter and analyze and say, hey, what causes this variation? Let's just look at the jitter, not the data, but the jitter. And we see that the Cayin actually has slightly lower jitter. We see that both of them have jitter, but the Cayin has a little bit less of it, except for this one spike over here at 16.5 kilohertz. There's something digital that's running in there, possibly the microprocessor that's controlling the front panel display, and is generating noise, and that noise is actually causing the SPDIF clock to dance back and forth proportional to this signal. So it's actually causing jitter on that transport. And that's not a good thing to have. So how do we know that's not a good thing? Let's take the SPDIF output of both of these CD players and run them into a high-performance DAC, in this case, topping D70S that's sitting on my desk. And when we feed it to that, again, this pulse train is supposed to be there. But notice this set of, oops, sorry, you're not seeing what I'm saying here. Notice this set of spikes here and this set of spikes in here. So the topping was not able to filter that out. And that Cayin's interference pattern from up here, it actually goes through the DAC and comes out the other end of a high-performance DAC. So you couldn't get rid of it. Now, the levels are at minus 120 dB, so about 5 dB lower than threshold of hearing. So it's not an audible thing, but just know that bits are not necessarily bits. We have basically, if you screw up the SPDIF clock, you will pay penalty in measured performance on this thing. Okay, so, but let's go back to, just using topping D70S and just looking at it, what it would look like. If you drive it by LINN, you get this idealized output of 93 dB. Everything looks cool. The noise floor is very clean. All looks well, so as good as 16-bit format can produce when LINN is the transport. But if you use the Cayin as the transport, what happens? Look at the same distortions we were seeing on his SPDIF. This time, those are data errors. Remember, I said the Cayin actually butchers the bits, the digital samples. Bits are not bits. So if you change the bits, the topping DAC faithfully reproduces them. And instead of just having 1 kilohertz tone, we have, this whole sequence. And now these things are rising up to minus 100 dB. They're not at a minus 120 dB, which clock jitter was. So bad news. This is just simply a broken implementation. It has a bug in it. And this is why you measure, by the way. It's not always for performance, also for functionality. Just measure this with even rudimentary devices. You could capture the bit stream over SPDIF into a computer and compare the bits. It would likely fail that kind of test. So not a good thing. Sorry to say. Hopefully the company will go back and find this bug and fix it on this thing. So we got that. Let's see if we can motor through these other ones. I don't know how, but we'll try. There's a company back in the 80s, or 70s or 80s, maybe it was 80s, that got quite a name for it called Tice. And it got the name based on something else that was even crazier than that. Some people bought this digital clock from then Radio Shack stores and brought it home, and they thought when they had this digital clock, innocent alarm clock, when the clock was running, they said their audio system sounded better. Don't ask me why that could happen, but folks believed it. Not only did they believe in that, this company, Tice, took, I think, the same clock and modded it and sold it under their own names and called it TPT. And then folks said that it sounded even better or different than the Radio Shack alarm clock. And I think this one was like $200-300. The alarm clock was only $30. And the thing was called the Tice clock. This was a digital clock, and created an incredible uproar between the believers and non-believers. And unlike today, there were a lot more non-believers then than there are today. People thought it was just a sign of craziness, and somebody would say, you go buy this thing and it improves the sound of your system by just having a clock plugged into the wall in your room. The company went bankrupt or broke. I don't know what happened to them. They disappeared for years and years. But then somebody sent me some of their products. Unfortunately, they didn't have the clock, but they had two other products. One of them is called the Tice Audio Enhancer. What's it called? TPT Enhanced Line Conditioner. There's almost no information out on these things. So I took it apart. It's a wooden box, and it's just something you plug into the wall. You don't plug anything into it, and whatever magic it does when you plug it into your outlet. So theoretically, it's cleaning up your power going into everything else, your whole house. So it has those screws, but the glue they had used was kind of flimsy, and so I just pried it up with a screwdriver and pulled the panel off. And what do you know? What's inside this thing? This sort of water kettle cabling they use goes in here and just loops and loops and loops, and then it sort of stops in this goop. The goop is the similar kind of goop they use to basically hide electronics. If you want to pot it, as we call it, you don't want anybody to be able to get into it. You pour the stuff in there and it solidifies and hardens, and that's that. So this thing is like a pound of this goop in here. And that's it. There's no active components in here. I don't think there's anything connected between the two ends. Literally, is a loop of wire just ending in here. And but hey, maybe there's some magic is performing in there that we don't know. So let's measure it. As always, I measure things by first measuring my AC line. So I have a special probe that divides the voltage by 100, so that it's not lethal anymore, but also it's differential, meaning that the probe is very good at not picking up noise from the air and imposing it. So what we're seeing truly is what's coming out of my AC outlet. And here the AC outlet, the AC waveform, we can see the tops of it are flattened because that's where we pull a lot of energy out of our AC line, so we deform it. And this is our main frequency, and when we deform it, we generate all this harmonic distortion and all this noise. So clearly it's a very, very distorted signal. It's got a 2.2% or 2.3% noise to signal ratio. 60 hertz and 122.3 volts. So what happens if we plug in this TPT device, Tice TPT, at the same time that I'm making this measurement? Answer is that not a thing changes. So, it didn't condition anything. All the noise is the same, all the distortion is the same. We're the same 2.3%, and nothing has changed. This little bit of change in voltage is just run-to-run variation, AC lines, not 100% fixed. So a little hard to overlay these two in your mind, but so let's just look at a Fourier transform where we put them on top of each other. And not only that, we go crazy, go to 1,000 kHz, so way past our hearing, which stops around here. And when we measure the AC spectrum in blue, we see that it has all this noise, and it's got some interesting, sorry, again, you can't see it. We've got all these spikes in here, and so definitely not a clean thing. But when we plug in the Tice TPD, nothing changes, even all these, high frequency noise, which would be trivial to shunt capacitor or something, and you just get rid of these. Not even that's been done. So that wire goes nowhere. Literally just goes in that goop, and that goop is an insulator, and there's really nothing there to change the signal. But you know how it is, people say, well, your ears can hear things that the measurements can't hear. Well, I was listening to music the whole time with my $4,000 Dan Clark Stealth headphones. They're reference quality headphones, extremely low distortion. And of course, they're sealed headphones, so the block outside noise. I'm just hearing music. You can't see my RME audio interface, but that's what's driving the headphone. And then the computer is plugged into the same outlet that all of this was plugged into. And I tell you, I plugged the thing in quickly, slowly, leaving it in, taking it out later. There's zero audible difference whatsoever in my testing. So it shouldn't make a difference. Measurements show that it doesn't make a difference, and clearly I didn't hear any difference. Now, the member didn't just send me this, it sent me this other oddball device. Apparently they made this power cable, this time it's a power cable, and one end of it, is male, the other side is the IEC cable that you plug in. But interestingly enough, it has two switches, it's got A and B written on it. So what the hell is that about? So I had a couple of security screws and took a bit of effort to try to open it. I opened it up, and all I see is the cheap little switches in here, and on one side nothing's hooked up. So basically either connects these two wires together or it doesn't. At first I thought this was the, in electrical circuits we have green is the safety ground, black in US at least, it means hot, and white means neutral. And basically the AC signals between the white and black. And I look at this thing and I'm like, wait a second, if you throw the switch to the right, you're basically disconnecting the neutral. If you did that, the device would shut down. Yet when I measured the two end to end with my meter, the continuity was there, meaning that it wasn't disconnecting anything. It wasn't until I peeked underneath this one and I saw that the white neutral cable, you can actually see it here, it actually also goes end to end. In other words, between the two ends of the cable, we have the same standard 3 wires going from one end to the other. In addition to those 3 wires, it has 2 more wires, one white one and one black one, and each one of them shadows their corresponding wire in there. So this black wire in here, this is a thinner black wire that goes to the same places this black wire goes, and same with the white wire. So on the white and the black on the 2 ends, they actually have 2 wires going to them, a beefy 14 gauge wire, or whatever this is, and a not so beefy, this little wire. Electrically, that's the only thing that's going to do when you connect that is that it lowers the resistance of the thick wire by a hair, because a thick wire already a pretty low resistance. Having another, 18 gauge wire next to it, it just changes the resistance, and that may maybe change the power capabilities of that cable from delivering, 2 kilowatts to 1.95 kilowatts or something like that. So it's not going to make a difference anyway. But surprisingly, they say that if you engage one switch, your bass changes, and if you switch the other one, your treble changes. Pretty amazing that just putting another wire in parallel with another wire would know to change the treble and bass and make things tube-like. So let's test the idea, though. I took a top-in D70S, again, that's always on my desk. So I measure it by itself. We see it's incredibly good sine out of 120 dB. Distortion's down minus 30 dB, so totally transparent. And so let's disconnect the standard cable that went into this and plug in our new Magic Tice cable in there. And we see that nothing changed. Actually, performance went down a hair because temperature changes and and you turn the thing on and off and measurement changed a little bit. So ignore that it got a little worse. Let's give him the benefit of the doubt that nothing got worse. I'll play with the switches while watching this display. Another thing was changing. The switches made no difference whatsoever. Now, if bass and treble are going to change, we better see that in frequency response. Obviously, we don't see it in frequency response. Frequency response identical, with or without the switches, with or without this cable. So this one absolutely positively does nothing. It's a really simple-minded idea of building a tweak, you know, compared to today. They talk about cryogenically treating this and nanoparticles that, and this material for the insulator, and I don't know, you know, a whole bunch of fancy claims. This one, it's just a simple idea. Let's hook an extra set of wires in there and put switches on them, let people play with them. Know that people thought it made an audible difference because you toggle some and your brain changes on this thing. So, you know, I'm not going to make a recommendation or not, but hopefully you understand there are a lot of crazy ideas out there, and some of these ideas go way back. And while something like this was easy to laugh at then, and a lot of people would stand next to you, today a lot of people think these things are real and they work, and you have a lot less people standing with you. Hopefully people can see that there was no magic in these products even then, and not a good idea to go chase those. Okay, we're going on almost 1 hour, I believe. We have 55 minutes, so I better stop here. Put in comments what you think of these long formats. Maybe you can speed them up as you watch them or jump around. And let me know if you want to see more of these. Okay, see you in a future video. Bye-bye.